Hi everyone, welcome to Quantitative Analysis Lab. In this course, you're going to get the opportunity to practice some very fundamental skills that are very important to being a chemist and a scientist in general. These skills are used in research labs, at companies, in this department, and all over the place by scientists all the time. And getting to practice these skills is very important. Learning how to do these things will help you essentially for the rest of your career. So we really look forward to working with you in this course. Now, a couple of things I want to say about this. Most of this stuff in quantitative analysis, believe it or not, you've probably done before in general chemistry. That's not to say you've done these exact experiments or you've done these applications of these techniques. However, for the most part, it should feel fairly familiar to you. But like anything, doing things a couple times isn't necessarily making you an expert at them. So for example, if you go for a jog or two, that doesn't make you a runner. If you try to play the piano or take a lesson or two, that doesn't make you a piano player. And doing one titration or even 5 titrations doesn't make you necessarily as good at that. So it's important to practice these things repeatedly. And this course gives you lots of opportunities to practice these things so that you can really dial in your skills and get good at them. It also gives you an opportunity to practice some of the mathematical calculations that are used commonly by chemists, including statistical calculations like standard deviation. So this is really a place for you to take those skills that you already have and really make them much better so that you remember them moving forward. And you can use these things, these different skills, as second nature. So we welcome you to quantitative analysis and we look forward to working with you. What I want to do in this video, it's going to be a pretty short video, is go over some general information, talk about what's going on before lab, and very briefly talk about the lab reports. Now, this video is not meant to be an hour-long lecture of everything you need to go over the course or the syllabus or any of this kind of stuff. It's just meant to give you a general idea of what's going on in this course so that you're better prepared. The first thing I want to mention is that you are going to be working in lab teams. Most lab teams will be 2 students. So you're going to have a lab partner and you're going to work with that partner to complete these different experiments. And I want to say a word about efficiency. Actually, I want to say a few. So first thing to know about efficiency is that you are going to be needing to think about how you're going to perform the lab before you get in there. So for example, in the first experiment, you're going to need 60 degrees Celsius water. It doesn't make sense to start heating water up 2 minutes before you need 60 degrees Celsius water because it's going to take more than 2 minutes to heat up. So you're going to want to do that while you're doing a previous part of the experiment so that that water is nice and warm and ready to go when you're ready for it. The other thing is there's going to be some opportunities to divide and conquer. So for example, if you're doing a titration, one person might be making solutions while the other person is setting up the automatic titrator. There are lots of opportunities to work on your efficiency. Efficiency is a skill that comes with practice and time. Use this practice and this time to increase your efficiency and work with your lab partner collaboratively in order to make the most out of your time in lab. I know your time is valuable to you, and if you work efficiently, you can literally save yourself time in the lab, which is very important to you, I'm sure, and it also gets you, kind of practicing those skills. So please do that. The next thing I want to talk about briefly is data integrity. We are not expecting all of your results and everything you do in this course to be perfect data. That being said, if you do a linear regression and your R squared is 0.75 and one of your points is clearly way off, you should remake that point. However, what you should not be doing is making up data so your data looks better. If your data has an R squared of 1.00, that is suspicious, not good. So basically, what we want you to do is use the data that you collect. Interpret the data you collect, even if it's not the most perfect data, even if it doesn't match some of the data that you see us present. Interpret what you have actually recorded. In many cases, the experiments are relatively short, so collecting that individual data point again won't take you very long. So if you have the opportunity in a lab and you know you have a data point that's not good, remake that data point. If you don't have time, interpret what you have. Tell us that you don't think this is the best data point, and maybe tell us why you think that. Next thing I want to talk a little bit about is the before lab. What are you going to do before lab? Well, one thing that we were offering that are new this semester, that are new for this semester, are pre-lab lectures. Now, getting all of you into the same place at the same time is an impossible task. So in order to best utilize or make it available to everybody, the pre-lab lectures are going to be online. And if you're watching this video, you already have a link to the playlist that will contain those lectures. They're not all done yet. Tim and I are going to work on them throughout the semester, but we will have them done before you do the lab. These lectures are ranging in time so far from about 45 minutes to an hour, so they are really a lecture, and they go over all kinds of stuff. The theory of the lab, what you're trying to calculate, the calculations themselves, Excel files, many of the things you can find in the lab manual, some general tips and tricks based on our experiences, and all this kind of stuff. So I strongly recommend that you watch the pre-lab lectures on this playlist before you come to lab each week. If you want, a trick is you can put them on 1.25 or 1.5 speed if that's tolerable, and you can still follow along, and you can save yourself a few minutes. But if you don't want to do that, they're only 45 minutes to an hour. They're like a lecture, and I think in the long run, they'll save you more time than they cost you, because it'll make it easier to do your outline, it'll make it easier to write your lab report, and you'll know what's expected. The next thing I want to talk about is the outlines. So for each section of the lab, you will be required to write an outline. And in the first experiment, I'm trying to find the outline here. In the first experiment, we talk about this outline in more detail. But essentially, section 1 is on solutions, and it covers the first 3 experiments. The red part of the outline is the stuff that you need to do before lab for experiment 1, because this is the experiment 1 outline. So before you come to lab, you need to think about all of the red bullet points here in your experiment. So we've labeled those red for you. In the video, we go over like all of this, so it won't be as intimidating after you've watched the video. The green part of the experiment 1 outline is things you're going to do in lab. And generally speaking, you're going to do a lot of this on an Excel file. So you're going to make some measurements, you're going to calculate some stuff, and then some other things that you could just type into an Excel file are interpreting the data. What does it mean? What does that data mean? Because numbers are one thing, but what the numbers mean are also very important. And then finally, the conclusion, which is what you're going to put into your lab report. So the outline is designed so that we can give you feedback on the experiment. So how it's going to work is you're going to come in for experiment 1 before lab having all these red parts filled out. Then the green parts, hopefully you'll have your Excel file pre-built, but then you're going to fill out with the actual data you measure in the lab. Then at the end of the lab, when you're done with experiment 1, you're going to hand in all of this pre-lab stuff, the red and the green. And your TA is going to give you feedback. They're going to say, this is great, you're doing well, you're on the right track. And then you're going to know what's going on because you're going to have that feedback moving forward. So this is an opportunity for you to organize your thoughts and for us to give you feedback on that, on your thoughts and also your data as well. So that's basically how it's going to work. Then for experiment 2, you're going to do the same thing. Experiment 3, you're going to do the same thing. After you've completed all 3 sections of the experiment, then you're going to write the outline into a lab report. And essentially all that is converting bullet points into paragraphs. So instead of writing these as bullet points, you're going to start to write them more as sentences and paragraphs and more of a lab report. If you have good outlines, the lab reports are not a lot of work in the sense that you can use all the data from the outlines to make the lab reports. So it's really important that you have good outlines. 1, it'll help you have a better understanding of what you're doing in lab before you do it, because a lot of the outline you're going to do before you come. 2, it'll allow us to give you feedback. And 3, it'll make your lab report really fairly straightforward to write. It kind of spreads the work out. So that's basically that. So please take your outline seriously. You'll be able to find this red, green, and blue outline in the description of the video, in this case for experiment 1. So right below the video on this playlist, in the description for experiment 1, you will find the this, so you can just download. Next thing I want to talk about is Excel sheets. So for each lab, you're going to have Excel sheets. And in these Excel sheets, this is the experiment one, you're going to basically record some data. You can have these Excel sheets pre-built, so they're ready to go before you actually come to lab. And that's a really good idea, because if you have this pre-built before you come to lab, the lab is going to be much smoother. You can even have the formulas plugged into it, so all you have to do is put in the measurements and it does the calculations for you. We do go over, mostly Tim goes over during the videos, how to make these Excel files. So we give you lots of details. You can see the Excel file in the experiment 1 video. You can see this exact Excel file, and we give you lots of details and tips and tricks for how to make these Excel files. Doing these before you come to lab, really good. Now, because you're working in pairs, this is one part of the experiment that is not going to be the same for both of you. So when you're writing your outlines, the written part, those should be different, right? You should write it in your own words with your own ideas and your own thoughts. Same for the lab report. So for your outline and your lab report, the writing part should be different. But the data part isn't really going to be different because you're collecting the same data. You're not both measuring the mass of the beaker. One of you is measuring the mass of the beaker and you're both using it to do it while the other person's doing something else. So you can kind of share this, and you can kind of, if you want, share the work. Talk to your lab partner, work together. Working collaboratively is also important. So it's an important skill to learn, just like efficiency, just like these different techniques, practicing these things, getting better at them, making them more second nature. It's great for you. So we give you that opportunity to practice here. Pre-lab questions. So the pre-lab questions are at the end of each experiment. And in bold, we actually give you the answers to the pre-lab questions. So you could put these numbers into Excel. Okay, you'd have to type them because you can't copy and paste them because you have a piece of paper. But you could put these numbers into Excel, calculate the average standard deviation and relative standard deviation, and make sure it matches our numbers. We are not going to collect this. This is for your benefit and your practice. If I was asked to calculate the standard deviation of these numbers and the relative standard deviation, it would take me about a minute because I've done it so many times. You want to get to the point where you've done it so many times, you're not thinking about what to type in, you're not looking at any kind of thing or watching a video, you just type it in and you go. And that, of course, takes practice. So we're giving you that opportunity to practice, and these pre-lab questions are designed to help you to make sure you're on the right track. Do you know how to do the calculations? Needless to say, these are the exact same calculations that you need to do during the lab. So if you can't do these ones, it's going to be hard to do the lab ones. So this is a good opportunity to practice. So please take advantage of that, but we do not collect these and you do not have to hand them in. Finally, the lab reports. After you go through the section 1, which is the first 3 experiments, you're going to have all these outlines. You're going to get, on the day you do experiment 3, you're going to hand in your outline. 1 week later, you're going to get it back. And then 1 week later, you're going to hand in your lab report. That's like a month from now. And it's going to seem like, you never hand in a lab report in this class. And then it's going to seem like you always have to hand in a lab report because after the first one, they come kind of rapid fire. So please be aware that you do need to do lab reports. The better your outlines are, the easier those lab reports are going to be. But I'm not going to go into a lot of detail on the lab reports because it is a month away and you're just starting the class now. So we welcome you to the course. I hope that you are going to work hard and be well prepared in this course because it's going to help you. It's going to help you not only for this course, because I want all of you guys to get an A in this course, but it's going to help you moving beyond this course. It's going to help you be more efficient with your time and organize your thoughts and do some physical manipulations and some mathematical calculations that chemists are doing all the time and scientists in general are doing all the time. So this is your opportunity to practice these skills. We look forward to working with you, and I hope you enjoy the course. Thanks for watching.